How to factorise a quadratic equation. Before we start factorising, it's very handy to have a look at what happens when we do this the other way round and we expand brackets. So in this example, we've got x plus 2 times x plus 3. If we expand this, we get x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. We then collect the like terms in the middle and end up with x squared plus 5x plus 6, a quadratic. Now by looking at this, we can see that the 5, the coefficient of x, was formed by adding together the 2 and the 3, and the 6 at the end was formed by multiplying the 2 and the 3 together. Now this fact is always going to happen, and we're going to use this to help us factorise. So let's look at factorising x squared plus 10x plus 24. So we know it's going to be of the form x plus m, x plus n. We just need to work out what m and n are. Well, we've seen already that when we expand brackets that look like this, we're going to get m times n will make the 24, and m plus n must make that 10. So we just need to find two numbers that will fit into this. 4 and 6, they work, so our solution is x plus 4, x plus 6. Here's another example, x squared plus 4x minus 5. So again, we're looking for an m and an n which will fit into our brackets. And we know that m times n is negative 5, being careful with our negative there. And m plus n must equal 4. A little bit trickier, but again, we can quite quickly see that m must equal minus 1 and n must equal 5. So our solution is x minus 1, x plus 5. Pause the video and have a go at these questions. The answers will appear shortly. Now when factorising a quadratic with a coefficient of x squared other than 1, it gets a little bit trickier. But fortunately, there's a quick method we can learn to help us deal with this. What we need to do is we take the coefficient of x squared and we take the integer on the end. So in this example, we've got 3 and 14. We multiply them together, so this gives us 42. What we need to find now is two numbers which multiply together to give the number we've just made, 42, and add together to give the coefficient of x in the middle, in this case 13. So we can see that the numbers that solve these would be 6 and 7. We're now going to split our 13x in the middle there up into 6x and 7x, just like this. Now it doesn't matter which way round you write the 6 and the 7, I've chosen to put the 6x first. What we do now is treat these four terms as two pairs. If we look at the 3x squared plus 6x at the beginning, we can factorise this because they're both multiples of 3x. So bringing the 3x out gives us 3x, x plus 2. We then factorise the second pair, 7x plus 14. So they're both multiples of 7. And bringing 7 out gives us 7, x plus 2. Now both these terms have got brackets of x plus 2 in them, so we can factorise further, giving us an answer of 3x plus 7 times x plus 2. Let's try the same thing with this example. We've got 8x squared minus 26x plus 15. So we multiply 8 by 15 to give us 120, and we now need two numbers which multiply together to make this 120 and add together to make negative 26. Note that we've got a negative here because our quadratic has got minus 26 in it. So this is a little bit trickier, but again, with a little bit of thinking, we can see that p must be negative 6 and q must be negative 20. So again, splitting the coefficient of x up, we've now got 8x squared minus 6x minus 20x plus 15. The first pair, 8x squared minus 6x, we can factorise 2x out of this, so it's 2x brackets 4x minus 3. The second one we can factorise out a minus 5, which gives us minus 5 lots of 4x minus 3. So being really careful with the negatives there. Again, we've got the same bracket in both terms, so we can factorise that out, which will give us an answer of 2x minus 5, 4x minus 3. Now this method will always work. We'll always end up with the same terms in those brackets at the end there, which we can then factorise out to get a pair of brackets. Pause the video and have a go at these questions. The answers will appear shortly. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.